Carter is playing a beanbag toss game, and in this game you can earn either 5 or 8 or 10 points for tossing a beanbag through different holes in a target. So, Carter hit the 10-point hole as many times as he hit the 8-point hole. And altogether, Carter managed to earn 99 points, while missing missing the target 25% of the time. How many beanbags did Carter throw at the target? Well, okay, you're 99 points. So, whenever he hit the 5-point, let's say he hit the 5-point hole M times, all right? And then he hit the 8-point hole, let's say N times, okay? And then it says that he hit the 10-point and the 8-point hole the same number of times, okay? So, so the number of points he got from the 10-point hole was 10 times n. Okay, so if we add this all up, this should tell us the total number of points that he got. Now we're assuming when he missed the target, he doesn't get any points. Okay, so this should add up to 99. All right, and because we know he hit the 8-point hole as many times as he hit the 10-point hole, we can actually combine those. And so we can write this as 5m plus 18n equals 99. All right, well, we got two unknowns here. And the other thing that we do know that helps us in this case, it may not seem like it at first, but we do know that m and n are, they have to be positive integers. Positive integers, right? And we know that because, we're throwing beanbags. You can't throw a negative number of beanbags. We can't throw half a beanbag, it's very unlikely. Okay, so we're not going to worry about the fractional beanbags. Okay, so we're going to assume that the number of beanbags he throws is a whole number. Okay, so that actually helps us. All right, it helps eliminate possibilities. So what I'm going to do, I'm going to rearrange this equation. I am going to write 5m is equal to 99 minus 18n. Okay, all I did was subtract 18n from both sides. And then I know that because this has to be a positive integer, that this thing over here on the right-hand side has to be divisible by 5. Okay, so it has to be an integer when it's divided by 5. So that helps me because I can actually rewrite this one in terms of, I can break this down into a number of 5s plus something else, or minus something else. In this case, I'm going to write 99 as 100 minus 1, okay, because I know 100 is divisible by 5. And then this 18, I could write it as 15 plus 3. I'm actually going to do it, I'm going to write it as 20 minus 2. So 20n, actually, minus 2n. All right. So 18 minus, or 20 minus 2, 20n minus 2n is the same as 18n. So I haven't changed anything. I'm just rewriting things in terms of a quantity of 5 plus a smaller number. So if I distribute this negative sign, I'm going to rewrite this again, and I'm going to put all the multiples of 5 toward the left-hand side. So this is 100 minus 20n. Okay, this is the multiple of n. And then the other part that I have is a minus 1. And when I distribute the negative side inside the parentheses, you can see this becomes a positive 2n, so plus 2n. Okay, now that's the same thing as 99 minus 18n. I've just rewritten it in terms of multiples of 5 and something else. Okay, so that way I know, it's a little easier to work with because I know that this whole thing has to be divisible by 5. This part is already divisible by 5. This 100 minus 20n is automatically divisible by 5, right? Because these are, 5 is a divisor of 100 and a divisor of 20. So what this tells me is that 2n minus 1 must be divisible by 5. Okay, and that's a little easier to work with, okay, rather than this 99 minus 18n, okay. So what I'm going to do is create a little table. Let me scroll down a little more, and let's see, where should we put this table? Well, let's put it right here because there's some room. Okay, so I'm going to choose some values of n and see what I get for m. Alright, so let's think about this. The first value that I could put in there now, n is a positive integer, so I can't put negative values in there. So the first positive integer I could put in there to make it at 2n minus 1 a multiple of 5 would be 3. Okay, because then that would be 6 minus 1, which would be 5. Okay, so what do we get when we plug 3 in for n? And since these are all equivalent, I'm just going to go back up to this equation here. So if I take 18 times 3, I end up getting 54. And then I have to, and that's a negative 54, because it's negative 18 times that. So then I'm going to take 99 minus 54, and what do I get? So that's 45. So 5m is equal to 45. So that tells me that m is 9 when n is 3. Okay? So let's see, are there any other values that would work? So there's a lot of them. Let's test the next one, which would be 8. Okay. Because 8 times 2 is 16 minus 1 is 15, which is divisible by 5. So that would be our next thing to check. And if we do that, you can see if I take 18 times 8, I'm going to get something that's over 99. That's going to be a lot more than 99. So that would give me a negative value over here on the right hand side, which would mean that m would have to be negative, and I can't have that. So anything bigger than 8 is not going to work, or anything bigger than 3 is not going to work, right? 8 doesn't work. So really, hey, look at that. We have one that works. So that tells us that, all right, so so we hit the 10 point, so 10 points, we hit the 10 point hole 3 times, so that gave us 30 points. We hit the 8 point, or Carter did anyway, we hit the 8 point, oops, the 8 point hole 3 times, so that gives us 24 points. And then we hit the 5 point hole 9 times. So 9, and that gives us 45 points. So if we add that all up, you can see that gives us the 99 points. And how many times did he hit the target and make points? Well, 9 plus 9 plus 5, or, sorry, 3 plus 3 plus 9 gives us 15. All right. So 15 of his beanbags hit the target and earn some points. Okay, but we're not done yet, right? Because we actually want to find out, well, we actually had to find out how many total bags he threw at the target, and we know that he missed 25% of the time. So this is only 3/4 of the total number of bags that he threw, okay? Because 25% of them missed, which is 1/4. Okay, so 1/4 of them mixed, 3/4 of them hit. So so we could actually write that as 3/4 of whatever we're looking for. Let's see, let's call it x. 3/4 x of x is equal to 15, which means that x has to be equal to 20. Okay, or you could think of it, okay, this is 3 times 5, so and then that's 3/4, so we'd have to he would have had to have missed 5 times. Okay, so he threw 20 beanbags. He missed 25%. He missed 5 of them, hit 15, and this is the distribution of points that he got. He hit the 10.3 times, 8.3 times, and then the 5.9 times. So there's your answer, 20.